All right, welcome back Science 30s to our next lesson in Chapter 4. This is 4.7, and today we're going to be looking at mutations. Okay, so in the last video, we talked about how we can go from DNA to messenger RNA to amino acids that we string together into a chain, which is going to be building a protein. But now we're going to look at what if when we're doing this copying process, an error occurs in the DNA. I'm going to show in here actually an error in the mRNA where that C, that green C, was accidentally replaced with an A. That's going to change this whole process because before when I looked up the CAG, that coded for an amino acid of valine. But now that I've changed that to an A, all right, the tRNA that is going to match that purple molecule, that's going to match this new mutated section is, if I line it up here, it'll be a phenylalanine. Okay, so I get rid of this chart and see that that's no longer the match that we're going to have, right? The purple doesn't match that mRNA. So now I need to get rid of that one, pull in a new tRNA, which brings in a different amino acid. So all this is really saying is if we make a change or have a mistake occurring in the DNA copying, we're going to have a change in the amino acid. This is building the protein, so we're also going to have a change in the protein. So just a little mistake in the DNA or mRNA is going to cause something different to be built, which is called a mutation. So just in the notes here, a mutation is an error in copying DNA or RNA. That's going to cause a change in this process of protein synthesis, meaning we're going to code for some different protein. So this change in protein is going to be building something that it wasn't intended to. Now this could be harmful to the organism, or it could be neutral, having no effect, or it could actually benefit the organism, giving it an advantage over other organisms. And this mutation could occur in somatic or body cells, and it could occur just in the individual, or it could come in gametes, which means it's going to pass that mutation onto its offspring. So either it can happen to the individual or the gametes to make the new offspring. And lastly, this could just be a natural occurrence, a natural copying error, but there are also some things that cause more mutations or cause copying errors as well, which are called carcinogens, and they could be a physical chemical, or it could be radiation, which also causes changes in the DNA and mutations. Okay, so now that we know what a mutation is, we're going to look at some different types. And the first type we're going to look at is a point mutation, which means a change in a nitrogen base is going to cause a change in just one amino acid for our first one, which is called a missense mutation. It changes just one amino acid. So the point mutation, we change one nitrogen base to something else, and now we're going to have a missense which affects one amino acid. So say we had this code of DNA, and that would normally, after the mRNA translation and then to the amino acid, would create these amino acids. If we had a mutation here where we change that to an A, in this case, we're changing one nitrogen base, that would change the code for that amino acid. It would no longer be histidine, and it would instead be glutamine. So we've just changed one of the amino acids in that amino acid chain. Another type of point mutation would be if we make the change and it doesn't change to just another amino acid, but it changes to a stop codon, which means stop making the protein at this point. So it was going to build a whole bunch of amino acids, but we switched one in the middle to end it at that point. So if we take a look at that example here, if we change that amino acid in this position, it's now going to code for stopping, and then we're not going to continue any building after this point. So that's called a nonsense mutation. And lastly, still on this slide, we have a silent mutation where we're going to change one of those base pairs, but it actually has no effect. So for example, if we change that to a C, and then we look up the type of amino acid that would be coded from that, it actually is still histidine. We saw before that if you look at that chart in your data booklet, some amino acids have two possible triplets or two triplet codons that could code for it. So if we made an error, but the thing that we made the error to actually still codes for the same amino acid, that's called silent because it's not noticed. It has no effect on the protein we're building. All right, so those were affecting the triplets and what those triplets code for, but it was just affecting one triplet. Now we're going to look at when it's going to affect a lot of triplets. Okay, these are called frame shift mutations. So we can have an insertion where we're going to add a nitrogen base, or we could have a deletion where we're going to remove a nitrogen base. And both of this is going to switch the triplets that we're looking at. So just to animate that, if we move this all over in this direction and add another nitrogen base, that's going to shift what sections we're reading. Like we have that first green section of CCA, and then before we had CAT, but now we have that mutation of ACA. But it didn't just affect the red one. The blue one got moved over, and the kind of yellowish brown one got moved over as well. So that shifted everything this way. That's why it's called a frame shift. And it's going to affect what everything this way is going to be coded for. And I know I have this example being the same. That would be a silent mutation since that change was no problem, but it doesn't mean we stop there. Everything this way was shifted as well. So the arrow is going to continue going all the way down in that direction. And we'll also just show what that looks like with a deletion. So if I get rid of that A or that base pair, and then I have to shift everything this way, I can see that then my red triplet, my blue triplet, and the kind of brown one here have all shifted, and I should have different types of amino acids being built there as well. So those are frame shift mutations. So now to conclude the video, we're going to talk about an application of mutations, which is mutating pathogens. So mutations just don't occur in humans or large organisms. Anything that is replicating DNA can have mutations. And for anything, this can create a positive, neutral, or negative effect. So pathogens such as bacteria, they're really small, but they're also going to have mutations that occur. And these mutations as well make different types, sometimes called variants, and they can be stronger, weaker, or the same. Now, many of the variants are going to be not as strong. That's probably on average it makes it not as strong, but a couple of them are likely to be stronger than the original version or the original strain. This makes them harder to fight off or harder to kill with different types of medicine. And that means when we try to fight them off with either our natural immunity or with medicine, the weaker ones are going to die off, but the ones that could survive are going to stay around. Then those are going to start reproducing and creating more and become the new dominant strain. So we went from a kind of weaker strain, one was stronger, we tried to kill it off, but only that one survived. So we left it only that there was stronger one left, it replicates a whole bunch, and now we just have a population of stronger bacteria or virus. Let's try and show that with an animation, that if I had this bacteria, it's going to start replicating, and maybe it's occurring in someone and making them sick, and we get a whole bunch of different bacteria being created. Okay, so most of them are the same. They're going to be those red ones, as we had a red original, but we see some different colors, and that's representing different variants due to mutation. There's some copying errors, and it's made slightly different bacteria because it coded for slightly different proteins. Most of these aren't going to be beneficial, but some are going to, just by chance, make them stronger. So then if we throw some medicine at it, so here I'm going to show maybe throwing some antibiotics to try and fight it off, that might have done a really good job at killing the original and some of the weaker ones. So they all die off, but because there was a mutation to make one stronger, just by chance that guy was resistant to the antibiotic. And if he's left over, he's going to keep living and reproducing, and all of a sudden make a whole new population of bacteria. And now these are all the stronger ones, so if we send more medicine at it, it was already strong enough to fight that off. And we can see we even have some new strains here, some again that could be weaker, but some that could be even stronger than that blue version. So bacteria, viruses are going to keep adapting to different ways that we fight it, like this as well. Now, as much as that does occur naturally, it also gives us some information about how we use antibiotics. That if we get a prescription for a certain amount of antibiotics for a certain amount of days, that's what's recommended to kill all the bacteria. If we don't take all of that, maybe we start to feel better, we say, I'm not going to take the rest, that might have wiped out all the bad bacteria, but there's a couple strong ones still remaining. Then they're going to replicate and become the dominant strain in your body, continuing to make you sick, and we've just kind of created a breeding ground for the stronger types of bacteria. So it's important to follow your doctor's directions on the antibiotics. And also, if we don't need to take antibiotics, because maybe we're sick with a virus or something like that, we'd want to avoid them if they're not necessary, so we don't have this happening more than it has to. Because again, the problem is if this has happened, then we send more antibiotics at it. These blue ones have already shown that they don't die from those antibiotics, so they survive and keep surviving, and we have a harder time fighting them off. And that's all that we have for this video. So I hope that helped you understand what mutations are and look at an application of them. Thank you so much for watching this video, and I will see you in the next lesson.